Assalamualaikum and a very good day to you all. My name is Dr. Ahmad Humaizi Bihilmi. I'm going to continue about the shaft material. All my notes is taken from this book, specifically in chapter 7, shaft and shaft materials, and all the pictures inside this note is taken from Google Images. Deflection is not affected by strength but rather by stiffness as represented by the modulus of elasticity, which is essentially constant for all steels. So what is a stiffness? Stiffness is the inability for a part to move. For this case of an automotive axle, you can see here this is an axle, specifically an automotive axle. This part does not move. Okay, so when the car, we can assume the car jump into a pothole, the front axle become deflect. This is the rear axle. The rear axle also can become damaged, but the damage is not shown as a deflection. Okay, students, the necessary for the shaft materials, the necessary strength to resist loading stress affect the choice of material and their treatment. Many shafts are made from low carbon, cold drawn or hot rolled steel such as AISI 1020 until AISI 1050 steels. So what does it mean? It means that to save money and to save cost, better to use low carbon or so-called low carbon steel. However, based on the calculation that you will learn in the next video, you will see that it all depends on what material, what structure that you uh, want to do. Okay. Now we are talking about fatigue failure on shaft. Okay, what is fatigue failure? The fatigue failure is reduced by moderately by increase in strength, but and then only to a certain level before adverse effects in endurance limit and non-sensitivity begins to counteract the benefits of higher strength. Okay, the picture here you see the brittle failure. This is the fatigue failure. This is the fatigue failure happen here. Okay, and this is also the fatigue failure happen inside the shaft when you cut the shaft, or the shaft exactly when the shaft is broken into two half. Okay, and this is the notch. Okay, notch is whenever a shaft you observe by your eye, there is a notch inside a shaft. On the shaft, you can be sure the failure will happen begin at the notch. Let's say the notch is here, can be sure the failure will begin at the notch and it will propagate and eventually the shaft will damage. So let's talk about choosing a shaft. Okay, it is a good practice to start with inexpensive low or medium carbon steel for the first time through design calculation. Okay, what does it mean? It means that whenever you calculate using the low strength shaft first because you will get the result. And the result, if your uh, if your calculated structure can support the low strength material, low strength shaft, you use that low strength shaft because you want to save money. If you start with expensive shaft, higher strength shaft, maybe of course it can support anything, but we're talking about saving money here, and so that is why calculate with the lower shaft first, then increase. If the material cannot support, the shaft cannot support, increase the higher strength, upgrade the higher strength until you get the shaft that can support the material, and you add with the safety factor times 1.0 times 1.2, 1.3, and then you get the result, and then you choose that shaft. Okay, let's say this is a higher strength material with smaller diameter, and this is a lower strength material with a bigger diameter. You see here, if you choose both of these, and with the certain geometry, you can find um, higher strength material can outweigh the lower strength material, because the lower strength material must be bigger to support the same structure. Okay, but it all depend on the cost. If you have the cost, you have the budget, you have the money, you can buy higher strength material and make the structure smaller. Okay, if you don't have the budget is not enough, you can buy uh, the lower strength material, but the diameter is bigger, and you the structure is logically to become bigger. Okay, typical alloy treatment include AISI 1340. Until you can read it. Okay, shaft usually don't need to be surface hardened unless it is a bearing, because bearing always exposed to elements such as dirt, water, sand, and etc. Okay. Okay, student, this slide talk about machining of cauldron shaft. Okay, when you buy the shaft from the factory, you will find it the most maximum size is 3 inches, 3 inches. Okay, so the parts that you need to machine is only the part that attach with the flywheel, with the shaft elements, that gear, like such as gear, flywheel, sprocket, and anything lah. Okay, uh, next semester you will do integrated design project or final year project. Okay, at that time you will buy shaft. Some of you will buy shaft. They come with a raw material shaft, and then what you have to do, you have to machine some parts, and other parts you don't have to machine. Okay, uh, only machine parts that required. Maybe you want to make it smaller, maybe you want to make it uh, surface better and everything. One thing you must remember: when you machine the shaft, it will become warping. If the shaft is too long, it become warping. And then if the concentricity is important, it may be necessary to heat treatment the shaft to remove the residual strength. Okay, this is warping, meaning that okay, I show you the shaft here. Okay, let's say this is a shaft and this is warping. You make it twist like this. Okay, you see the twisting effect, make it warp, and then the diameter of the shaft, the concentricity is not center. Okay, if the concentricity is what is important to you, then make it uh, take extra precaution. Okay, I'm telling you, for the next semester you will buy shaft. Some of you will do some final year project related to some machining. Okay, and you buy a shaft, and this turning machine here, you will use this turning machine whether CNC machine or manual machining. Okay, eventually you will do some machining to make the shaft smaller, make the surface polish and everything. Okay, this is the production of shaft. And when you are talking about the mass production of shaft, you will do um, the forging and everything lah, the one that you have learned in manufacturing technology class before. So that's the video for now. See you in the next video on shaft layout.